Thank you, Eamon, first of all, for, I guess, inviting me to this event. It's really a pleasure to be here. And I'm excited to kind of be talking about, I would say it's kind of like a similar topic to some of the things I've talked about in the past, but it's actually a new presentation. I'm kind of, you know, thinking of different ways to really try to describe and talk about some of the ideas that me and my team are having, and what I see as kind of the future of full stack development with React and really just any front end JavaScript or really mobile framework at all, mainly focusing on full stack cloud development. So anyway, I guess I'll go ahead. This is going to be broken up into two main pieces. So I guess I should go ahead and share my screen because it's going to be a slide presentation for the first 10 or 15 minutes, and then I'm going to be doing quite a bit of live coding. So let me share my screen. Can you see my screen okay?
Yeah, it's fine.
Okay, cool.
Yeah.
So my talk here is called Rapidly Prototyping, and you've probably heard of the term rapid prototyping, but I think what I'm proposing here is kind of the next step for what we, I guess, think of when we think of rapid prototyping and kind of the next generation of what we're going to be doing, in my opinion, for building not just front end applications, but really a new idea around what is front end, what is back end, what is full stack, and how does cloud computing fit into all this as front end developers. Okay, so I didn't know I had all these transitions. Sorry, that was kind of interesting. But anyway, my name is Nader Dabbit, and I'm a mobile and web developer, first off, and that's what I've been for the last 9 years. I've also started writing a couple of books recently. So I've written React Native in Action, which is a React Native book focused on mobile development with JavaScript and React. And most recently, I wrote Full Stack Serverless. And my title right now is a senior developer advocate working at Amazon Web Services on the client technologies team. And my most recent book, Full Stack Serverless, is really something that is going to be very similar to some of the topics we're talking about today. And this was actually released 2 weeks ago. It's available on Amazon and Kindle and all that stuff. So if you're interested in what I'm talking about, check out that book. You can read the first chapter for free. So I guess when we're talking about rapid prototyping, let's first describe like what this means. And originally, rapid prototyping was a term meant for more industrial type of uses. So if you need to create a car part, for example, and you needed to maybe see if it worked with these other car parts, a rapid prototype would basically mean you fabricating something locally. But the software industry has also picked up this idea of rapid prototyping. And the term, from what I have been able to put together, this is the definition: the process of developers quickly creating prototypes and simulating the future state of a website or software system. So what are the things that you might consider when you're thinking of rapid prototyping in your head, at least to me, the characteristics? Well, when you think of just prototype in general, you typically think of something that's not really production ready. You think of something that is just almost like a toy or a demo. You don't typically think of these things being an actual scalable real world use case. You often think of them as being fragile. And the assumption is that at some point in time in the future, it needs to be rewritten because it's just a prototype. It's not something that you're going to ship to production. But what I want to do is challenge this idea of what if we can take the scalability of something that is real and combine it with the benefits of rapid prototyping. And okay. So I guess to kind of talk about the ideas that I have, I guess we also have to kind of take a step back and talk about what has changed since the days of this old school ideology of rapid prototyping being more like a fragile thing versus what I'm going to be proposing in just a moment. And I think the core fundamental thing that has changed is this idea of serverless computing and the tooling around serverless computing. As a front end developer, which is what I am, serverless and cloud computing was not something I was truly interested in up until maybe the last couple of years. Because as a front end developer, I had enough stuff to worry about. I have to deal with, Webpack, and I have to deal with all this Babel, and I have to deal with new frameworks and state management and all of the things that come along with all of that. So why would I care about serverless computing? So let's talk about what the definition of serverless computing is first, and how this is actually going to be applicable to me as a front end developer. Well, in the past, serverless computing, when it first was coined, was essentially talking about functions as a service or serverless functions. So when serverless first came out, it was actually a framework that was kind of, or actually the serverless framework was kind of the first framework built around this idea of serverless functions or functions as a service. And the serverless framework was kind of the first tooling that came around this idea of dealing with these functions as a service. And when we talked about serverless, we just essentially were talking about these functions that were basically, you know, would just spin up when you invoke them and they would go away, and that was kind of it. But over time, serverless computing has actually evolved to more of like a philosophy. And when we talk about serverless computing now, we're not just talking about serverless functions. We're talking about more of the philosophy of building things in a way that is quote unquote serverless. And some of the benefits and I guess characteristics of what serverless is some stuff that we'll go over. But essentially, it's a combination of a couple of things. And if you actually look at some of the research that's been done, for example, I guess by Berkeley, they came out with a paper last year talking about the future of cloud computing, and the future, in their opinion, is serverless computing. And serverless computing was recoined in that paper, and this is really kind of what we've been heading towards anyway. Is instead of just functions as a service, it's kind of now defined as a combination of functions as a service and managed services or backends as a service. So kind of managed services, backends as a service, serverless functions, and taking these things and saying, okay, when I want to build something, I'm going to try to take advantage of something that is already there versus reinventing the wheel. And I am going to try to leverage someone else's machine essentially and someone else's computing power and only pay for essentially what I'm using. So, what are the benefits of this idea of serverless as it stands today? Well, most of the time, you're going to be getting a lot of different things out of the box. First of all, less complexity because you have less code. So, for instance, if you are creating a web server, you might in the past have created your own first server to just kind of like get the web server running. You needed a server. You then needed to install an SSH into that server and install a bunch of dependencies. You had to worry about uptime. You had to worry about a lot of different things around patching and maintaining that server. But when you're working with serverless, you're essentially just working with either a serverless function that's managed and maintained by someone else, or a managed service that's also managed by someone else. So you don't have to deal with that. You don't have to deal with the complexity. You don't have to deal with the maintenance, the patching. You don't even actually have to deal with the code because that code is managed by someone else. The only thing you're worried about is writing that business logic that can differentiate you or your company from everyone else. You also typically get developer velocity because instead, again, of reinventing the wheel and writing something like an authentication service from scratch, you might reach for a managed authentication service that someone else has been working on for the last 5 years and they know it from front to back. All you have to do is hook into these APIs, and what you're going to get out of the box is a working service, something that has probably scaled massively based depending on how many customers that service is maintaining or I guess supporting. You're going to get people that have specialized in that thing for years on end, and they've hit all these different edge cases, and all you're doing is paying for that service as you get users. So if you don't have any users, you're not really paying for that service. And therefore, if you're not creating that from scratch, you're going to have faster iteration because you can then just hook into these things. And that's just one example, managed authentication service. Also think about managed backends as a service, managed databases, anything like a machine learning services, all those different things. You're going to have a lower cost in a bunch of different ways. First of all, you're going to have a lower cost as a developer or hiring developers, because if you're not creating this from scratch, you're not having to spend as much money to pay a developer to create it from scratch. You're also going to be trading capital expenditure for variable expense. So instead of creating a server and paying for that server to be running, you're only going to pay for the invocation time of that function running or of that service being used. So let's say that you come up with the startup idea and you think that if you get the target that you'd like to get, you're going to need X amount of, you're going to need to scale to X amount of users. So therefore, you're going to provision all these resources, all these servers, and it's going to maybe cost you $10,000 a month. But let's say it takes you 2 to 3 years to get to that point, and you're sitting here spending, $10,000 a month on this infrastructure over the course of a few years. That's about $400,000, whatever. You could plug in different values there. But if you're working in a serverless environment, you're only paying for the usage. So if you don't get users for 3 years, you're not actually paying for barely anything, if anything at all. And then once you get those users, then you worry about that cost. And that's usually an easier discussion to have if you're a startup. Um, and it's just an easier thing to deal with, because if you have customers, you're probably able to either get money from those customers or you're able to get investor money. Therefore, you're able to scale your company and have longer runway. And then the one of the big ones is just that they're typically more stable and secure. If you have a team of 5 people and you're trying to build this big thing, and you need this authentication service, are the 5 people on your team better than the 100-person team, or whatever, this 20-person, whatever team that it's been maintaining this authentication service for the past 5 years? And they have customers that have like 100 million users, and they've dealt with all these edge cases, and they've focused and they've really specialized in this thing for all these years. Is your team capable of building that? Maybe, but more often than not, I would say no. So just by definition, that service will probably be more stable and secure than what you're dealing with. Of course, there's trade-offs here, because when you're dealing with the service, you're actually buying into that feature set. So if you need a feature that isn't there, you're not going to be able to get it. So that's one of the biggest trade-offs, in my opinion, is that you are limited to the feature set. Now, you might be able to, ask for something, or you might be able to find workarounds, and you might be able to again, ask for that thing to be implemented, and down the road it might be added. But that's kind of the big trade-off, in my opinion. So at the end of the day, though, I think when we're talking about rapid prototyping, and the key differentiator and the main important thing, in my opinion, about all this stuff, it's developer velocity. The key differentiator, when you look at a lot of these startups that are coming out, is the ability to iterate and try new things and maybe pivot, and just be able to build without a lot of, you know, I would say that that expense of having wasted time for something that didn't actually work. So, what are, I guess, the challenges when you're working with serverless? Like, why, if this is so great the way I'm talking about it, why isn't everyone building in a serverless environment? Why is Kubernetes still a big deal, and Docker? And why is everyone still managing their servers? I think if you look at this tweet by one of my favorite programmers and one of the smartest people that I know, that I follow on Twitter, Avdi Grimm, this was in March of 2019. It was only about a year ago. He said, "I spent 3 hours with one of the smartest engineers I know, with help from viewers on his Twitch channel, or whatever his live stream was, following the AWS Cloud Lambda docs, trying to get one Lambda function deployed, and it never happened." And this is one of the best programmers in the world, right? He spent 3 hours trying to get just a simple function running. This isn't even talking about plugging in all the different things together that you need to make a serverless environment work. He's just trying to get a single function working. He can't do it. That's because we had a lot of work to do to get the developer experience and everything together to make this an actual, you know, lower the barrier to entry, I would say, for everyone that hasn't been doing it. So to me, the main challenges in the past, and this is the thing that I think is being addressed today, were the high barrier to entry. So if you weren't a cloud engineer, you probably had a lot of issues building a real serverless environment and maintaining it. The developer experience was bad. The tooling just wasn't there either. And when you're working with serverless, one of the main problems in the past has been the inability to do local testing. So that's just serverless. But me as a front end developer, I'm more interested in the full stack vision of things. So, what are the challenges for a full stack developer to kind of come into this environment? Well, first of all, there are multiple platforms that need to be supported for working with these APIs and stuff. So let's say I'm a mobile developer or I'm a web developer. the SDKs are just all different. And the documentation for these SDKs typically hasn't been that good in the past across all of the cloud providers. Um, this is just for making simple API calls, but then you start getting into stuff like authentication and authorization, security concerns, signing your headers and making sure everything is done properly and secure. And then you're tacking on a lot of extra things. And all of this stuff put together is actually very challenging. And then most importantly, when you look at serverless documentation or you look at cloud documentation, it's actually focused on people that are cloud engineers or backend engineers, and they don't even talk about the front end. So if I'm a front end developer and I'm seeing all this stuff, it's very confusing. I'm like, how? Okay, so this is cool, but how do I actually call it for my front end? How do I actually make all this stuff work? So there was no cohesion between the front end and the back end. But I think this is all being addressed today, and I think that some of the stuff that my team is working on, and also some of the stuff that you see at Google and Microsoft, they're all also addressing this stuff. And essentially what I'm seeing is this idea of full stack cloud or full stack serverless, where they're recognizing the opportunities that are there, and they're trying to solve these problems and improve the developer experience by providing a few different things. So first of all, end-to-end tooling. So if you're a front-end developer, the idea on our team is we want to be able to make you be able to bring your existing JavaScript or front end skill set or whatever your skill set is, be it native iOS, Android, Flutter, React Native, whatever. Bring that existing skill set, and we want to provide the tooling to allow you to use that to build these full stack cloud applications that do scale, that are not just fragile prototypes, that are real cloud applications with best practices baked in. We need to provide the client SDKs for making these API calls and abstract away a lot of the complexity that is necessary for everything to work properly and be secure. So if you're a native iOS developer, if you're a native Android developer, or you're a web developer, we need to provide these SDKs that make these API calls easy to do, and also integrate well with the front end environments. We need to have cohesive documentation for both the front end and the back end. So if I'm a front end developer, I want to build this full stack application, I need to know how to build the back end. I need to know how to build the front end. I need to know how to make it work together. And this is a challenge, and it's something that I think that we've been really tackling on our team. And it's actually extremely powerful when you get it right. We are building higher level abstractions for mainly these client SDKs, actually for the backend tooling as well. But essentially, in the past, if you wanted to build a cloud application, you had to understand really complex, very cloud related things like infrastructure as code, or you had to understand how to glue a bunch of things together using IAM roles and being in the AWS console, which is really confusing. We've built higher level abstractions in a CLI based environment, and we're actually working on a few other things that we're going to be releasing at the end of the year that make this even easier. And then escape hatches, because when you have this level of abstraction, you have to be able to have a way to escape and take full control for things that are not yet supported. And what this is, in my opinion, and I'm actually seeing this at startups, a lot of the big startups that we're working with, is that we're seeing kind of a change in the way that engineering teams are being organized. Whereas before you had a feature team, I'm sorry, as before you had a platform team, now you're having like a feature team. So if I need this API implemented to be able to fetch this list of items and render them to the screen. In the past, what I would do I would get my front end developer to implement the client side code. I would have a back end developer creating the API, and then the front end and the back end developer would talk to each other and they would iterate and they would make stuff happen. And the front end developer would be like, "Oh, this doesn't work," change the data structure, and you would have like this back and forth. But I think the future is where you have a feature team, and one developer can actually build the full stack. And again, I think what you're seeing is in the future changing the way that these engineering teams are organized. And what you're essentially seeing is like a cross stack engineer. So they're working across the front end and the back end and DevOps, and they're doing kind of everything, because when you have one person implementing the end-to-end solution, if you make it easy enough, it actually makes a lot more sense that way. And it's a lot faster because you don't have to wait for this backend engineer to respond to your email or to get back to you. They might be busy doing something else. The developer velocity is hurt big time there. So what are some of the benefits of doing of building in this way? Well, you have enhanced developer velocity. This is a big, again, differentiator when you're talking about opportunity cost. If you have a way to build 2, 3, 4, 5 times faster than your competition, you're going to have a big leg up over them, regardless of many other factors. Being able to experiment kind of goes along with this developer velocity and opportunity cost. I think the developer velocity, experimentation, opportunity costs are all kind of like very, very coupled together because they all kind of have synergy off of each other. You have this idea of a cross-stack engineer versus a front-end engineer, a back-end engineer. And I say cross-stack because it's, you could say full stack, you could say whatever, but essentially they're kind of, going back and forth. And they're more of a feature developer versus a platform developer. And what the ideal, end goal is, these prototypes or this rapid prototyping, the results should be a scalable code base and an infrastructure that does not need to be rewritten. If this thing works, it should be shipped to production, and this should be it. We shouldn't have to go back and rewrite this thing because it's not just a toy. If we do things properly and these best practices are put into place, then everything should be good to go. And one of the big goals for us is enabling front-end developers to become full-stack cloud developers, just using their existing skill set and plugging into these different APIs and abstracting away that tooling. So like if you look at GCP and their move to enable serverless functions and other data sources into Firebase, you're seeing them kind of move into this direction. I've heard that Microsoft is building some stuff in this area as well. And then my team at AWS has built AWS Amplify, and that's kind of what my demo is going to be. But I'm not here to evangelize AWS Amplify. I think all of these things are great choices. Of course, I work on this team, so I'm kind of big on it. But I think more of the idea that I'm trying to convey is that this is kind of the future, and I think it's a really great space to be in as far as like making money and having opportunity in the future. But Amplify is kind of built using, or I would say it's kind of like broken up into 3 main parts. We have the CLI and the client libraries, and this is kind of the main bread and butter of what Amplify is, these 2 things. The CLI is a front-end CLI that allows you to configure and create and update your back-end resources in your AWS account from your front-end environment. So you're kind of working everything from your front end. And then we have the client SDKs for native iOS, native Android, React Native. We even have these client libraries for React and Vue that allow you to kind of get up and running with some stuff. And we're going to take a look at that in just a moment. And then we also offer a static site hosting service that kind of also is a portal for you to see your backend infrastructure that's been deployed using the CLI. And some of the categories that we support right now, within these categories, there are many times multiple different services, but we have authentication, we have REST and GraphQL APIs, Lambda functions, storage for images and videos, databases, machine learning, hosting interactions, and push notifications. And we're adding a few more. And we also have video, and video is a way to do live streaming and stuff like that. The live demo I'm going to be doing is a video demo, but the newly released video CLI, we added a new service called Interactive Video Service, which is what Twitch uses. And it was just released like 2 weeks ago, but the video is still in beta. So I'm probably not going to use the CLI for the video, but I'm going to use the CLI for everything else until that comes out of beta, because I don't want to break during a demo. So what I want to do is kind of just give you an example of like a rapid prototype. And what I want to do is try to build out a live video streaming app similar to something like Twitch. And I want to do this, in the next 20 minutes or something like that, or however much time I have left. So what I have right here to start off is I'm in a React project, and all I've done was just create the project. So if I run npm start, then we're going to see that, we just get started with this really basic web project, this React project that you've probably seen 100 times before if you're a React developer. And what I want to do is I want to turn this into something like Twitch. So the first thing I'm going to do is I need to have that video service, and I could run Amplify. I think it's Amplify add video, And this will take us through setting up a couple of different video service.
Sorry, another.
Oh, I haven't. Yes.
I think the screen sharing got paused. So for me, I just see your slide for now, like with
Oh,
live.
okay.
So
I'm sorry about that.
no worries.
What about now?
Yeah, I still have the same. Yeah, I still
Okay,
see
let's
the
see.
live coding, because maybe in Zoom you can. I know you can choose to see one app and not the whole screen.
Yeah, it says my screen sharing is paused, and let me try to stop sharing and then restart again.
Yeah.
Okay, what about now?
Yeah, now we see the React app.
Okay, cool. So like, yeah, what I have here is a React app, and it's pretty basic. And what I want to do is I want to add, the video service. So like I mentioned earlier, I could, if I create an Amplify project, I could run Amplify add video. But because the new video service, the one that I want to use is just in beta, I'm going to go ahead and like create a new service in the AWS console. So I'm just going to go to interactive video service, and I want to create a new stream. And again, what we're going to be trying to create is kind of like a Twitch-like experience. And I'll call this BeJS. And I can either choose default or custom configuration. This is just going to kind of let us switch between HD and low latency. And I'm just going to kind of take the defaults because I think for this example, I want to use low latency. So what you get after you create the service is you get a ingest server URI, you get a stream key, and a playback URL. And all you have to do is take this playback URL and plug it in any video player. And the ingest server and the stream key is what you can use for OBS. So I'm going to go ahead and open OBS. And in OBS, I'm going to go ahead and start a stream by clicking on settings. And I'm going to go to stream, and I'm going to copy this ingest server, and I'm going to copy, this stream key. And we're just going to test out the stream because we want to make sure it works before we write our app. And I'm going to click start streaming. Okay, so after we start streaming, we can wait a couple of seconds, and what we should see is we can actually go into this live stream portal. And once the stream is actually started, we should see the status switch to online, and we should kind of see just an example of the stream. So now we see that the stream is live, and you kind of see that working. So we have a real live, a serverless, I would say, like, when I say serverless, it's kind of like a managed service for live streaming. So we have that running. What we want to do is embed that in our app. So what I want to do is go back to my React app, and I'm going to install React Player. And I'm going to also install some Amplify stuff. So I'm going to install AWS Amplify and AWS Amplify React. And the Amplify UI React is React UI components. And then I'm also going to install React Router DOM because we're going to need routing later on. And to test this stream out, I'm going to go to my code base and just go ahead and open this up in my text editor. And I'll zoom in to make sure everyone can see. And I'm going to go into just like app.js. And I'm going to go ahead and import React Player from React Player. And in the app itself, I'm going to go ahead and maybe like have this React Player running. And what we basically need to do just to kind of maybe get this basic example up and running is I might just add some styling here. And then the last thing we might do is just wrap that in a div. Whoops, it looks like that. Let me go back and try that one more time. Okay, there we go. And I might just add some styling here, and we're just doing inline styling because we just want to make this fast. And then for the React player, what we need to pass in is the URL. And then we also maybe want to pass in like a width. And for the URL, I can just copy this URL here. So go ahead and pass that there. And we'll try this out. Go back here and refresh. And we have that. And it looks like we have our stream there. So what I want to do is actually set the playing flag to true. And this is kind of something you can toggle with some React state if you want to. But for us, we just want that there. So we have the stream going. So that's pretty cool. What I want to do next is just stop the stream, excuse me. And what we want to do now is add the features around the app that you might think of. So when you think of Twitch, you probably think of chat. You probably think of authentication. You have to sign in to be able to chat. And you probably have an idea of who's in the chat, because when that person creates a comment, we can see whose comment that is. So we want to add all of that. So how can we do that in the next like 15 or 20 minutes? Well, what I want to do is I want to initialize a new Amplify app. So I can run Amplify init. And this is going to initialize a backend for us, like an AWS backend. So we'll provide a name for the project, a name for the environment, our editor, and then it's going to notice that we're in a React app, and we can just choose the defaults for all of these settings, like build command, start command, all of these questions. And then the last thing we're going to do is choose our AWS profile, which is essentially the user that we want to create all of this stuff under. And this is going to take about, I guess, 30 seconds or so. And what we're essentially doing is, okay, we're saying we want to create a new Amplify app. So we're going to deploy a base project structure in the cloud. And from there, we're going to then be able to add all of the different features that we want. So really the two things that we need are authentication and an API. So a couple of things around the API. You probably want to make sure that you have some authorization rules set around the API. So for instance, if I create a comment, I want to be able to update or maybe delete my own comment, but I don't want other people to be able to do that. But I do want other people to be able to read my comment. So I might add rules around that type of stuff. So we need to keep that into consideration. So to do that, the first thing we'll do is just run amplify add auth to add authentication. And this is going to walk us through a couple of things. We can either do a manual configuration and set a bunch of things, or we can do a default configuration with kind of smart defaults. And for this example, that works great. And I'm just going to choose username for signing up and then no advanced settings. And then now we have our authentication service configured. The last thing I guess we need to do is add a GraphQL API. So I'm going to run Amplify Add API, and this is going to walk us through either creating a REST API with API Gateway and Lambda or GraphQL. For the API name, I'll choose that. For the default authorization type, you know, if you think about Twitter, or you think about Instagram, or you think about even like a blog like Medium, you typically have multiple authorization types. So if I'm not signed in, I can still go to Twitter and read tweets. If I am signed in, I can go to Twitter and read tweets. But I can't delete someone else's tweet unless I am the owner of that tweet, right? So like those are the things that you think about when you're adding these authorization types. So we need multiple authorization types because we want public access and we want private access, meaning that if someone signs in, they need that. So what I'm going to do is choose a default authorization type of public, which is just going to be an API key, meaning like anyone that sends a request with this API key can make a read. And then I also want advanced settings to set an additional auth type. And the auth type that I'm going to be using is Cognito, which is a managed authentication service. If you've ever used something like Okta or Auth0, it's pretty much the same thing. And then conflict detection is for working with offline stuff, and we're not too worried about that. And then if we have a GraphQL schema that we already want to use, we could reference that, but I don't. So I'm going to say no. And instead, I'm going to choose one of these templates to work with. And this is going to now let me edit the schema in my text editor. And this is going to be kind of the data model for our app. And the only thing that we really want to enable is comments, right? So I guess what I'm going to do is use a type of comment that has an ID, a message for the comment. And also we have a couple of other fields because we might want to sort by created at, and we want to have that field available. And we also might want to know who the owner of the comment is, meaning who created it. Now that's great, but like when you create a GraphQL API, you need a database, you need all of the different resolvers, you need all the other stuff. Well, we have this at model directive, which is part of Amplify. And this model directive will actually scaffold out all of those things that you need to get you started. And then you can then modify any of that stuff with your own custom business logic. So this will give us CRUD and list operations. It'll give us resolvers, and it'll give us a comment table. And then the last thing we need to do is model some authorization rules. And we can actually do that here by using the @auth directive and passing in a rules array. So for each rule, it's essentially kind of like a map with key value pairs and stuff. So what I want to say is I want to allow the owner to have full access of the comment, meaning they can read, but they can also update and delete it. I also want to say allow public and set the operations array to only be read. And when you define the operations, you're kind of defining what this person can do. And I'm saying if someone just is a public user, they can read comments, but they can't really do anything else. And then I also want to allow people that are signed in but are not the owner to have that same access. So I can say allow private, and then operations set to read. And then I think that's all we need. So we have allow owner, allow public, operations read, allow private, operations read. We should be able to close the schema and go back to our CLI, and then we're ready to actually deploy all of this stuff. So I can run Amplify Push, and this is going to deploy the backend infrastructure. And then it's also going to go into our GraphQL schema, and it's going to introspect our GraphQL schema, and it's going to create GraphQL operations locally in our React project, and a folder that's going to be showing up here under the source directory with all of the operations that we'll need on the client in just a moment. So that being said, like we have this backend being deployed, let's now write the client side code to do all this other stuff. So the first thing we need to do is go to index.js, and we want to configure Amplify. And essentially what we're going to be doing is we're going to have this AWS exports.js file here. And this is going to be populated for us by the CLI with all of the resources. And all we need to do, we don't need to ever edit that. All we need to do is just import that. And then the CLI will keep up with it. We just need to call amplify.configure and pass in that configuration. And that configures our app to work with all that stuff. So we've configured our React app. What we're going to need now is some routing, because if you think about Twitch, you know, it has these different routes and stuff. You might have a route to sign in. You have a route to view the stream. So I want to have two routes, one route to view the stream and one route to have authentication. So I guess the first thing we might do is create the actual component for authentication. So I'll call this auth component. And I actually have already some code that I've written that I'm kind of like gonna drop in here, but I'm gonna walk through what's going on. If you look in the return statement here, this is pretty interesting because all we're doing here is having 4 lines of code in this component. We're basically having this user variable that we're using, that we're kind of defining on component creation using the useState hook, and we're just setting it to null. And then therefore we can check if there is a user, we want to show their greeting with like hello username. That's one thing. So how do we actually populate that user variable? Well, we're using the set user call using useState, and in the useEffect hook, we're importing the auth class from Amplify, and there's a method that you can call called current authenticated user. And if there is a signed-in user, this just returns that user object, and we can then call set user, and then therefore we know that there is a user, and we can show them this greeting. And then 2 other things. To add authentication to any component, we can use the with authenticator higher order component from the UI React library. And all we have to do is wrap that component with this UI component. And what this is going to do, it's going to put an entire authentication flow in front of this component. So when this renders, if they're not signed in, it's going to show them a sign up form, a sign in form, a forgot password, all those things you would typically need in an auth flow, but we get it with like one line of code. And then the last thing we want to offer is a way for them to sign out. So what we're doing is just creating this sign out button, and this sign out button will call essentially a function called auth.signout under the hood, or you could create your own button and just call that yourself. But here it's just a little less code. So this is kind of all we need. In 20 lines of code, we have some authentication going. And what I'm going to do is go ahead and import that component. And what we need now is a router. So the router that we're going to have is going to be having just two links and two routes. So we're going to have a link to the stream, and we're going to have a link to the profile, which is going to be where we're going to be able to basically use that authentication component. And the path for home is just going to be, a slash or a root. And then the path for authentication is going to be auth. So we have that. And we actually have all that stuff running, essentially working. So all we need to do now is export the router. But I think the one thing we haven't done yet is we actually need to import some of this stuff from React Router DOM. So I'm going to go ahead and import routes, hash router, link, and switch. From React Router DOM. So we have the auth component, we have our router, we have our main app component. So let's save that and go back to our app and see if we have any errors. So it looks like we have our links working. And it looks like if we navigate to auth, we do indeed see our authentication flow. So what I want to do, I'm just going to zoom in so everyone can see. I'm going to go ahead and create a new account. And it looks like I have some type of error going on. Oh, it looks like our backend resources haven't been deployed completely yet. So these need to be finished deploying. And I think this is maybe taking a little bit longer because I have OBS maybe running, which usually destroys my computer. So we'll wait for a couple of seconds there. But I guess one other thing that we can do while that deployment is happening is I can actually go back into app.js and do a little more work, because we're going to need some similar functionality that we have in our auth component, where we're kind of working with the user. So I might just copy this code here and go into the app component. And I'm going to go ahead and import a couple of things. Okay, go ahead and import auth and API from AWS Amplify. And then we'll go back. Oops. I need to import use state and use effect. And I'll also import use reducer. Okay, so now we'll go back to the React app and we'll try this one more time. So we should be able to now create an account, and what's going to happen is we should get an email with a multi-factor authentication code. And if this works, we should be able to sign in. And there we go. So we're signed in, we have authentication working. We should be able to kind of navigate between these two. We should be able to sign out, should be able to sign back in. Okay, so that's great. We have the authentication part working, but I think the next thing that we need working is the comment section. So we need a way to create comments and manage the user state also as well. Because if someone isn't signed in, they shouldn't even be able to see the comment form, much less create a comment. So what we can basically do is, now that we have this user that we've created here, we can now make another div for our comments. And here we might use some similar styling as we did here. And maybe we'll give this a width of 300, a margin left at 20. See how that looks. So this is going to be our comment section here on the right. And what I want to do here is I want to basically say, like, if there is a user, then show them the comment form. So we're going to go ahead and write out the comment form. First, we want to have an input, and we want to have a button. Create comment. And for the input, I want to have like an onChange handler. I want to have a placeholder. And I need to have a value so we can control this input. And I might call this input value. So we have two variables that we haven't created yet. So we need to create a variable for input value and also for onChange. So to do that, we'll just go to use state, and we'll go ahead and say const input value set input value is equal to use state, and we'll pass in like an empty string. And then we need an onChange handler for when the user types. So this is essentially just going to call set input value, and it's going to be attached so when the user types, and it should only show up if the user is signed in. So if we go ahead and refresh, we see that the comment form is there, and if we sign out, the comment form goes away. So we're on our way, and then the next thing we need to do is actually enable comments. So to do that, we'll go back to our code here. And I guess the first thing we need to think about is how we're going to manage that comment state. So in the past, I would have probably said if you're working with an array or something like that, something basic, use state. But since we're going to be actually dealing in just a moment with real-time data, and we're going to be working within a closure and a subscription, we're going to actually need use reducer. So what I want to do is create some initial state that's going to have a comments array. And that's all we're going to need for our state. And also we're going to need a reducer. And the reducer is going to have really just two actions. When we fetch comments from our API, we're going to call set comments. And this is just going to return the comments array populated with the comments coming in from the action. And then we're going to have a case for adding a comment. And this is going to be used in two different ways. First, it's going to be used for an optimistic response when we're creating a comment locally. And it's also going to be used when we're doing a subscription for real-time comments coming in. So now that we have those two things created, what we can do now is implement those in our app. So I'm going to go down here, and I'm going to go ahead and create state and dispatch. And we're going to now set this to equal use reducer. And we're going to pass in the reducer and the initial state. So now using this, we can now create a function to create a comment in our API and also create the optimistic response. So to do that, I think the first thing we need to do is actually have the GraphQL operations imported. And when I mentioned earlier that we create the GraphQL locally, you see now that we have this GraphQL folder and we have a create comment mutation that's created for us. We don't ever have to touch that. It's already there. It's managed for you based on your schema. So what I can do now is, I guess I'll go ahead and find out which of these imports. There we go. Here we're importing create comment. That's the mutation that we're going to need. But we're also importing a couple of other operations, list comments and on create comment for real time. But the one we're working with now is create comment. So I'm going to go back down to our app. And I'm going to have a function called create comment. And this function is going to do a couple of things. First, we're going to check if there is no input value. So if they haven't typed into the form, we're just going to return. We're going to then take the input value and store it as a variable so we can provide an optimistic response by clearing out the form. and then another optimistic response by populating the local comments array with that new comment. And then the actual API call against our API that we created is right here. And the GraphQL client that Amplify has enables you to essentially make GraphQL calls like you would a fetch or an Axios call, where it's kind of an asynchronous call. And we're passing in different arguments. So here we're passing in the query, which is kind of the GraphQL query, which in this case is create comment. We're passing in any variables. And then we're also defining the auth mode if it's not the default auth mode. And since our default auth mode is public API key, we actually need to override that because we're essentially assuming this user is signed in. And then I think the last thing we might do, since we're creating an optimistic response, then we should have that comments array populated as soon as someone creates a comment. So we should be able to say state.comments.map. And we should now be able to map over these comments. So what I want to do is I want to say, I guess, have an H3 or something like that with the comment.message. And then we'll have a span with the comment.owner. And this is kind of going to say who's, the message itself and who sent the message. Okay, so let's save that and we'll give this a spin. So no error, so that's good. So I'm going to go ahead and say comment, or I'll just say hello world or something like that. Create comment. And it looks like something is not working. I think I know the problem. I think with the button that we created, I never attached the onClick handler to create comment. Try that one more time. And there we go. So we have our comments being created. And if I want to check out the database, you can run Amplify Console and kind of view that. But instead, let's actually fetch the data from the database, and that way we still know it's there. And I might use this index to kind of just get rid of that key warning. So to fetch the comments, we're just going to basically need to call a function and use effect called fetch comments. And we have everything set up. We have our reducer set up. All we need to have is a function that basically kind of like makes that API call. So this is just a few lines of code here. We're going to be calling api.graphql, passing in the query of list comments, pretty simple query. And then we're going to dispatch the action for updating the comment list. And then now when we save and re-refresh, we should actually see the comments array already populated. So if I refresh, it's there. I'm going to say comment 2. And we see that the comment comes through. And then if we refresh, the comments are there. The last thing we want to do is add real time, because if you go to Twitch, you see people creating comments. They come through. You don't have to like refresh to see those. So what we would like to have is we open a incognito window. We want to be able to kind of see these comments coming through. If I create a comment on one side, we want to see it coming through on the other side. And to do that, we're going to create one more function called subscribe. And in subscribe, we're going to be doing this work right here. Whoops, go back up. We're calling again. We're using the same API class, calling api.graphql, and instead of passing in a query or a mutation, we're passing in a subscription, which returns a different type on the API class. So instead of it being like an async await type of deal or a promise, we're going to be able to call this .subscribe method on it. And then in .subscribe, we're going to have a next function that fires anytime a comment is created, or if this was on delete comment or on update comment, whatever this operation is, that's when this subscription would fire. And you can also pass variables here. So if you have like a chat app and like a room ID and that type of stuff, you can do that. When the next function fires, we're going to have the data being passed into the function as comment data. And I'm just going to get rid of the console.logs because they're kind of pointless at this point. And we're going to destructure, some data off of the comment data. And we're going to have two circumstances here, because what we need to think about is this. If the user is signed in and they created the comment and we've already created the optimistic response, then we do not need to populate that local array because that data is already there. That's the one circumstance that we do not want to populate that array. The other two circumstances we do want to populate that array because that means either the user is not signed in at all, which means they could not have created that comment, or they're signed in and they did not create the comment. So those two circumstances, we need to basically account for 3 different circumstances. And that's kind of what we're doing here. We're basically going to check who the user is. If they created the comment, we're going to return. If they did not, we're going to add the comment. And if they are not signed in, we're also going to add the comment. And then I'm going to go ahead and start my live stream again, and we're going to test the final result of this out. Looks like the live stream should be up and running. We'll give that one more second to see if it comes through. There it goes. So our live stream is back. What I want to do now is create a comment in real time comment. And there we go. We see the comments coming through over here in real time and did not duplicate over here. And that's kind of what was our goal. And the last thing we can do is go to the terminal and run Amplify Console and then kind of view our backend and everything in the console. And here we see like all of the categories, authentication, API, and then in the API, we can actually see the table, which is DynamoDB, and we can kind of see if the items are there, which they are. Okay, so let's see here. That is actually the end of my talk. So thank you for watching. And if you have any questions, feel free to follow me on Twitter at Dabbit3. I'd be happy to chat anytime. Thank you. And I'll go ahead and stop sharing my screen.
Thank you, Nader, for this super nice presentation. It's pretty awesome to see how fast you can go and how rapidly you can actually deploy and do something with the new serverless technology.